So let's see. Let's start with maybe this one. Let's say we have 2 over 3 minus 4 over 5 all over 4 minus 7 over 10. Okay. So there are really two strategies for doing this one. You can reduce the numerator and the denominator before doing anything else, and then work with the compound fraction afterwards, or you can reduce it out of a compound fraction initially and then simplify at the end. So maybe we'll do both, just like for practice. So let's go ahead and simplify the numerator and the denominator first, keeping in mind that having a big numerator and a big denominator is like being in parentheses. So that's like your grouping. So in the order of operations, parentheses, exponents, and so on and so forth, it's like the first one because it's like parentheses. Okay, so that means we need to combine 2/3 and 4/5, which means we need a common denominator, which will be 15 in this case. So we can multiply this one by 3 over 3. This one by 5 over 5 to give ourselves a common denominator. Then down here, we need a common denominator of 10, keeping in mind that 4 is the same thing as 4 over 1. So we can give ourselves a common denominator here by multiplying this one by 10 over 10. Okay, great. So this is going to give us, so here we'll have 10 over 15. So 10 over 15 minus, so here we'll have 12 over 15. So 12 over 15. Great. And then here we'll have 40 over 10 minus 7 over 10. Great. And now we can go ahead and combine the numerators and denominators because we have everything with common denominators. So here we can do 10 minus 12, so that's going to be -2 over 15. And then we can simplify the denominator as well. So 40 minus 7, so that's going to be 33 over 10. And now we're taking a quotient of two fractions. And so we can use the rule that whenever you take a quotient of two fractions, you multiply by the reciprocal. So this is going to be -2 over 15 times 10 over 33. Yeah, there, I took the reciprocal. Now you can maybe cancel as needed. So we can think about this 10 as being 2 times 5, and this 5 as being 3 times 5. That allows us to cancel this 5 out. And then we can multiply across, so that's going to give us -4 in the numerator, so -2 times 2. And then we've got 3 times 33 in the denominator, so that's going to be 99. Okay, so that would be like one strategy to do it, which is maybe like simplifying the numerator and the denominator in depth first. And then maybe another way would be to clear as many fractions as we can before starting. So let's maybe go ahead and do the first step of that. So I'm just going to copy this over. So 2/3, 4/5, and then 4 minus 7 over 10. So essentially what you want to do here is look at every denominator. So you've got 3, 5, and 10. And then think about a number that if you multiplied by that number, you would cancel all of the denominators. And so technically it's like the least common multiple of these three numbers. So the least common multiple of 3, 5, and 10 is going to be 30. So if I multiply the entire numerator by 30 and the entire denominator by 30, I can actually simplify my life quite a bit. So if I do 30 times this 2 over 3, so notice the 30 and the 3 is going to cancel down to 10. And then we'll have 10 times 2, which is 20. So here we'll have 20 minus. And then here we have this 30 is going to cancel with this 5 to give us 6. And then, well, let's see, we'll have 6 times 4, which is 24. All over. And then we do the same kind of thing here. So 30 times 4 is 120. And then 30, well, it's going to cancel with this 10 down to 3, so it's going to be minus 21. But now we end up with the same thing. So we end up with, well, 20 minus 24 is negative 4. 120 minus 21 is 99. So either one is fine. You know, I don't know. Maybe like I am partial to doing this because it's like faster, but you know, it doesn't really matter. Okay, cool. So let's maybe do a couple more like this, and then I'll split you guys into groups to work on a couple by yourself. We'll do that for like 20 minutes or something, and then we'll come back and do the next stuff. Okay, so the next one is 3 to the minus 1 minus 4 to the minus 2. So this one, in fact, is like a little bit quicker than the last one that we did. It just, you need to use the definition of negative exponents. So let's maybe recall that real quick. We recalled this last time, but just for good measure, we'll recall it again here. So if you have a to the minus n, that's going to be the same thing as 1 over a to the n. So whenever you have a negative exponent, it's like having a positive exponent in the denominator, and then vice versa. So that means we can change this to 1 over 3. Well, it's really like 1 over 3 to the 1, but that's just 1 over 3. And minus 1 over 4 squared, because the negative 2, it's like an elevator downstairs and you have like 4 squared. Yeah. So now maybe write this as a third minus 1 over 16. And then we have to find a common denominator, but the common denominator will just be the product of these two, which means we need to build this up by multiplying by 3 over 3. And then we'll build this one up by multiplying by 16 over 16. So that's going to give us 16 over 48. So 3 times 16 is 48. And then minus 3 over 48. So in the end, we'll get 13 over 48. And then you should check real quick, is that reducible? But this one is not reducible. Yeah. Okay, cool. So this is like a good one for recalling like what negative exponents do. Now, let's do another one that's like kind of quick that involves square roots and stuff. Okay, so let's say this. Let's do the square root of 12 minus the square root of 75. Okay. So this seems like maybe we can't even get off the ground because 12 is not a perfect square and 75 is not a perfect square. But we are actually in luck because even though these are not perfect squares, we can factor them in a way so that they include perfect squares. So, and the motivation for doing that is the fact that they're in a square root. And so we want to simplify as much as possible. And so in order to simplify a square root, we want to introduce a perfect square if possible. So here we can write 12 as 4 times 3. And here we're using the fact that 4 is equal to 2 squared. And then we can use the fact that 75 is equal to 25 times 3. And 25 is equal to 5 squared. And so that simplification will help us quite a bit. So let's see what we get. So we can rewrite this as the square root of 4 times 3 minus the square root of 25 times 3. Good. And then we can extract these perfect squares from the square root. So we can take the 25 out of the square root and the 4 out of the square root, but we have to take their square root while doing that. So 4 coming out of the square root will become 2. So we have 2 times the square root of 3 minus 5 times the square root of 3. Again, because 25 coming out of the square root will give us 5. And so now we've got 2 root 3 minus 5 root 3, so that's going to be negative 3 root 3. Because we can think about them like as like terms or whatever, like the square root of 3 term is the like term. And then we'll split off and do some that are pretty similar to this, but are good practice. I mean, this stuff is not like super inspired, But it's super important for, like, I mean, the whole point of the class is to get ready to take calculus next year or whatever. And this stuff is like super important for success in a class like that. So, okay, let's look at this. We've got 3 times 5 to the 100 over 12 times 5 to the 98. Okay, and so the point of this problem is to recall like some exponent rules. So let's recall really quick that if you have a to the m over a to the n, that's the same thing as a to the m minus n. So if you have the same base, in this case the base is a, and you're dividing two exponential things with that same base, it's the same thing as subtracting the exponents. And the reason why this problem is really working towards that is because it's essentially impossible to calculate what 5 to the 100 is or 5 to the 98 is. That's not something you would want to do. So that means we can take this. Well, first of all, we can get rid of the 3 and the 12 and make that 12 in the denominator into a 4, because 3 over 12 is the same thing as 1 over 4, because 12 equals 3 times 4. And then we can take care of the other part. So here we're going to have 5 to the 100 minus 98 over 4. So that 4 is there because of the 3 over 12. And then we're subtracting the exponents because of this rule, which is like boxed in red. But now that's going to give us 5 squared over 4. But 5 squared is 25. So we end up with 25 over 4. So let's see. The first one is like this. We have 12 over 5 minus 7 over 24 all over 1 plus 12 over 5 times 7 over 24. So we really want to think that having big numerators and denominators means that we need to think of that as grouping. And so if we think of that as grouping, that means we need to simplify the numerator and the denominator as much as we can before we do our next step. So keeping that in mind, we have a fraction in the numerator, and so we need to find a common denominator for that fraction. And so the common denominator will be the product of 5 and 24. And so we can multiply this by 24 over 24, and then this one by 5 over 5. And let's see what we get for that. So just the numerator, so maybe like kind of offhand, you want to think that 24 times 12, so that's going to be like 2 times 12 times 12. So that's like 2 times 144. So this first one is going to be 288 over, and then 24 times 5, so that's going to be 120. So maybe like, let's color code this. So this is equal to this. And then minus, so we've got 7 times 5, so that's 35. And then 24 times 5, so that's still 120. But that was the point, was to get a common denominator there. So, okay, so now we do the same thing here. Maybe like before we move on to the next step, maybe notice that this is a product of two fractions. So we can just take this product. So 12 times 7 is 84. 5 times 24, well, that's lucky because it's the same thing up here, so it's 120. And that tells us that we need to write this 1 as something with a denominator of 120. So we'll use 120 over 120. Now we can rewrite the denominator as 120 over 120 plus 84 over 120. 253. So we've got 253 over 120. So that's what we get for the numerator. And then the denominator will have 120 plus 84. So that's going to be 204 over 120. And then next we can use, like, when you divide fractions, you multiply by the reciprocal. So this is going to be the same thing as 253 over 120 times 120 over 204. But the good thing here is that those 120s cancel. And then after those 120s cancel, we're left with 253 over 204. Good to look at. So let's look at the sixth one. We have the cube root of -2 minus the cube root of 54. And then we're taking that and squaring it. So this one's a bit tricky. Is that right? No, there's supposed to be a negative here. Negative. Okay, so there are a couple of things that maybe you have to do first before you start squaring. And the first thing would be to factor the minus sign out of the cube root. So if you have an odd root, you can always factor the minus sign out. If you have an even root, like if we had the square root of -2, well, that wouldn't make any sense because that's not a real number. So odd root, you can factor it out. Even root doesn't make sense, so we wouldn't really see it. So if we do that, that's going to give us negative the cube root of 2. So we just factored the minus sign out. And then here we'll factor the minus sign out, and that'll cancel this one. So it'll be plus the cube root of 54 squared. And now you want to look at this and think that either you can't simplify it anymore or there must be a trick. And the fact is there's a trick, and that's because we can take 54 and write it as something cubed times something else. And so the motivation for doing that is because it's inside of a cube root. So if we take this 54, we can write it as 2 times 27. And the important thing here, maybe I'll put like a circle around this. The important thing here is that 27 is equal to 3 cubed. So what that means is that the cube root of 27 is equal to 3. And so that gives us quite a bit of simplification. So now we can rewrite this a little bit. So we can rewrite this as negative cube root of 2 plus the cube root of 27 times 2 all squared. So I just like factored that 54. But using this fact up here, we can take this 27 and factor it out. But if we factor that 27 out, it's going to become a 3 because the cube root of 27 is 3. So that's going to give us negative the cube root of 2, and then we have plus 3 times the cube root of 2 all squared. And now we're actually in really good shape because we have like terms. So we've got a single cube root of 2 here, it's negative, and then we have 3 cube roots of 2 here. And so when we add them, well, it's going to be like 3 minus 1, or negative 1 plus 3. So we've got 2 cube roots of 2. So in the end, we're going to have 2 times the cube root of 2, and then we need to take all of that and square it. But now we're in good shape because no longer do we have this thing which is being added together and then squared. We just have a single term which is squared, which means I can take the square and put it onto each of the ones that are in there. So that's going to give us 2 squared. Well, 2 squared is 4. And then the cube root of 2 squared, but 2 squared is still 4. So we end up with 4 cube root of 4. And that's like as far as you can go, because anytime you could try to simplify the cube root, you would look at the cube root and say, okay, well, now can I take that thing which is inside the cube root and write it as something cubed times something else? But you can't do that with 4. It's like too small. It's not in the right spot, right? And just kind of keeping in mind that 1 cubed is 1, but taking that out doesn't really help. 2 cubed is 8, 3 cubed is 27, 4 cubed is like 64 or something, 5 cubed is 125. So just like keeping those cubes in mind can tell you if you can simplify or not. And here you can't really simplify. So let's look at this 7th one. So we've got 3 times the square root of 2 times 4 plus 1, good, and then plus 3 times 4 times 2 times 4 plus 1 to the negative half, and then that times 2. So here, this is like a real practice of like doing parentheses, exponents, and all that kind of stuff. Keeping in mind that all of this being inside of the square root is like being in parentheses. So following the order of operations, we want to do parentheses first. So that means we want to do everything inside of here first. So 2 times 4 is 8 plus 1 is 9. So we have 3 times the square root of 9 plus, and now we can go ahead and think about what this is. Well, that's also 9 because it's 8 plus 1, which is 9. So we've got 3 times 4, so that's 12, and then 9 to the negative half times 2. Okay? Now, we want to keep in mind that a negative exponent is like being in the denominator, so we can rewrite this as 3 times the square root of 9 plus 12 times 2. I'll just bring that, and then now we have 9 to the half in the denominator. But now you want to remember that the half exponent is the same thing as the square root, so we can write this as 3 times the square root of 9 plus, well, we know what 12 times 2 is, so 12 times 2 is 24 over the square root of 9. But now we can use the fact that we know what the square root of 9 is. So the square root of 9 is 3. We could have done that simplification for part of this, like way back, but we just didn't. So the square root of 9 is 3. So that makes this 3 times 3, which is 9, plus 24 over 3. But 24 over 3 is 8, so that's 9 plus 8, so that's 17. So it's really just a matter of being careful, like working from the inside out. Inside, I mean like inside of all the radicals and stuff, and parentheses, and then applying all of the exponent rules and stuff like that carefully. Like negative exponents push you towards the denominator. Fractional exponents are like roots, and so on and so forth. Okay. So again, like we recalled at the very beginning, we have like, if we have a to the minus n, that's the same thing as 1 over a to the n. In other words, like a negative exponent is the same thing as taking a reciprocal or putting something in the denominator. Now, if you've got something that looks like a fraction, that is still true, but it's often like useful to simplify it even more. So this minus sign is going to flip these, and then you'll get an nth power of each one. So here we'll have b to the n over a to the n. So see what happened here is the minus sign flipped a over b to b over a, and then the fact that the entire fraction was raised to the nth power put each of them to the nth power. So often, whenever you have one of these problems with fractions and exponents or negative exponents, you'll see it kind of like this, and you'll want to do it all at once. But what's happening in the background is really you're taking this as b over a to the n, so that minus sign did the flipperoo first, and then you can distribute the exponent onto everything. Okay, so now that's exactly what we're going to want to do in this one. So we've got this 5 over 12 all to the negative first power, and then this 5 over 12 all to the negative second power. So we'll apply this rule down here to each of those. So let's see what we get. So this is going to give us 2 times 12 over 5, like that. And then let's see. Down here we'll have 1 minus 12 squared over 5 squared. Right? So here we did the flipperoo, and then we had to raise it to the second power. I mean, essentially we did the same thing over here, except we raised it to the first power using this rule, but raising it to the first power doesn't do anything, right? So x to the 1 is equal to x. Okay, so now we're pretty much all set. We can go ahead and simplify the numerator and the denominator like we did in this first problem that was on the sheet. So let's see. So when you multiply fractions, you just multiply across numerators and denominators. So we want to think of that about that 2 as 2 over 1 in order to simplify. So that gives us 24 over 5 over, and now we've got this 1 minus, and then 12 squared is 144, 5 squared is 25. Good. Now we need to simplify this denominator, keeping in mind that having a bunch of stuff in the denominator is like being in parentheses. So that means that all of this stuff is like an invisible parentheses. So we want to take maybe this 1 and rewrite it with a denominator of 25, but we can do that just by taking that 1 and rewriting it as 25 over 25. And now we're ready to go. So we can rewrite this as 24 over 5 over. So now we need to do 25 minus 144. So, you know, I don't know what that is off the top of my head. So 9. So it looks like it's 119. So it's negative 119 over 25. That seems to be what we get. But now we're taking the quotient of two fractions. We're dividing two fractions. So that means we need to multiply by the reciprocal. So if we multiply by the reciprocal, we'll have 24 over 5 times 25 over 119, like that. And then we can start simplifying. Oh, and I need a minus sign. And actually, we can just put the minus sign out in front of everything. There's a single minus sign, so that contributes. Everything is negative. Okay. Now we can start simplifying. So notice that this 5 will cancel this 25 down to 5, because 25 divided by 5 is 5. And then we're essentially done. We've got 24 times 5, which is 120. So we have 120 over 19, and it is negative. So we've got 12 times negative 5, then negative 5 plus 3, all to the negative 4, and then plus 6 times negative 5 squared times negative 4 times negative 5 plus 3, all to the negative 5. There's a lot going on here. I mean, but the trick is just to take it like one thing at a time. So parentheses come first. So that means we want to take this negative 5 plus 3 and combine that. So if we have two instances of that, one right here and one right here. So we can maybe combine it both times. So negative 5 plus 3, that's going to be negative 2. Negative 5 plus 3 is negative 2 over there as well. And that it's going to give us, oh, and then maybe while we're at it, and it seems like maybe we're not doing order of operations, but we are, because these things aren't interacting with each other. We can go ahead and take care of this 12 times negative 5, again, because we're not combining it with this other thing. We're just doing it on the side. So 12 times negative 5 is negative 60. And then we can do the same kind of thing over here. Maybe we'll do this negative 5 squared, which is positive 25. So whenever you square a negative number, you get a positive number. Okay, so now let's see where we are. So now this big first term here is negative 60 times the quantity negative 2 to the negative 4. Something like that. And then the second term is going to be 6 times 25 times negative 4. So I just took that square so far. That's all I did. And then I have a negative 2 to the negative 5. Okay, now we can like keep going with the rest of it. So we're going to, again, use this rule that if you have a to the minus n, that's the same thing as 1 over a to the n, in order to send our things with negative exponents to the denominator. So that's going to leave me with negative 60, and then here I'll have negative 2 to the 4th. Right? So what happened here is that this negative exponent, it's like an elevator. It took me downstairs to the denominator. And now negative 2 to the 4. So we know that'll be positive because it's an even number of things that are negative that we're multiplying together. So negative times negative is going to be a positive. But negative times negative times negative will be a negative because 2 of those cancel and we're left with the negative sign. But here we got 4 of them. So it's going to cancel out and we're going to be left with 2 to the 4th. So 2 to the 4th is 16. So we're going to have a positive 16 here. Then just on the side, that's negative 2 times negative 2 times negative 2 times negative 2. So all the negatives cancel and we're left with 16. And then next, let's see what we have here. We have, well, we can multiply this in any order we want because multiplication is associative. So we might as well do 25 times negative 4 because that's the easiest one. So that gives us negative 100. So we've got negative 100 times 6. So that's going to leave us with negative 600 in the numerator. And in the denominator, we've got negative 2 to the 5th power. But that's going to be negative 2 times negative 2, negative 2, negative 2, negative 2. So in the end, it's going to be negative because we have an odd number of minus signs. And then 2 to the 5th is 32. So we've got something like that. But if we've got a negative in the numerator and a negative in the denominator, those are going to cancel. So that cancels to a plus. But now we need a common denominator. But it's not so hard to find a common denominator because if we take 16 and we multiply it by 2, we'll get 32. So take 16, multiply it by 2, but if we multiply by the denominator by 2, we also have to multiply the numerator by 2. And so that's going to leave us with negative 120 over 32 plus 600 over 32. Okay, sweet. Now 600 minus 120 is 480. So we're left with 480 over 32. But now this is not in lowest terms because they're both even. So we'll have to cancel until we get it in lowest terms. So notice we can divide each by 2. We'll get 240 and 16. So that would be dividing the top and the bottom by 2. But then we can keep going. So if we do it again, we'll get 120 and 8. Then if we do it again, we'll get 60 and 4. If we do it again, we'll get 30 and 2. And then finally, if we do it again, we'll get 15 and 1. So this is actually just 15. The next couple of things we're doing are going to be linear equations and then inequalities and then equations and inequalities involving absolute values. And then we're kind of moving on like that. So maybe as we talk about how to solve linear equations, maybe we need to think about 2 rules that can be used in order to simplify an equation. And so the first rule is you can add the same thing to both sides of the equation. And what I mean is that you can do that and it does not change the overall meaning of the equation. So if you have a statement that is true, you add 2 to both sides of that mathematical statement that's true, then the new statement is also true. So 10 is equal to 10. Add 2 to both sides, 12 is equal to 12. That's still a fact. So that's the kind of thing that's going here. Really, it's like add or subtract, but you know, subtraction is just like addition with a minus sign, so it's okay. And then the next thing that we can do is multiply each side, or maybe both sides, by the same number. So both sides of the equation by the same, and this is like really important, non-zero number. It's important that it's not 0, because if you multiply both sides by 0, well, you've destroyed information, because everything times 0 is 0. Good. So these two rules are really all you need in order to solve these linear equations. So we're going to start off small, but then we'll work towards ones that are a little bit more complicated, and they're kind of built off of our, so I think you can hear my kid screaming. Sorry about that. That's the situation. So I'm sorry, I'm distracted now. And then we'll build up to more complicated ones that will involve us being very, very careful with the order of operations. Yeah, good. So let's look at this maybe. 2x plus 1 equals 5x minus 11. So let's say we want to solve that. So these are the only two rules, and maybe we can even rename this instead of rules. These are like allowable actions. So these are actions you can do to an equation that are allowable in that they do not change the information of what's going on. Okay, so we want to get all the x's by itself, right? So in the end, we want to have x equals something all by itself using these two rules only. There's someone upstairs with her, so she's fine. I'm just not here by myself, and she's like killing her brother. Okay, so anyway, we want to add the same thing to both sides of the equation. So what I want to do is maybe I'll add -1 to both sides of the equation. So that gets all of my numbers to one side of the equation, and then we can work on everything that involves x. So after doing that, I have 2x equals 5x minus 12. Then next, I can add a -5 to both sides of the equation. Sorry, I should say a -5x to both sides of the equation. And that doesn't change anything because, again, yeah. Yes.
Would it be okay if you added 11? So
yeah, it's fine.
Minus 2x to 5x.
Yeah, that's totally fine. You can do it in any order you want. It's the same. Yeah. Okay, so let's see. This is going to give us a -3x on the left-hand side and a -12 on the right-hand side. And then we can use the second allowable action, which says you can multiply both sides of the equation by the same non-zero number. But multiplying is the same thing as dividing. So here we can divide by -3. That's the same thing as multiplying by -1/3. So, but, you know, often it's a little bit more familiar to think about it like dividing. So I'll divide both sides, and that'll leave me with x equals 4. So there, we did a simplification. Notice we used this first allowable action twice, and then this second allowable action once. Okay. Let's go ahead and look at maybe one or two more that they're essentially the same level of difficulty, but they involve like kind of injecting this more complicated order of operations into them. Okay, so let's say maybe this one. 1/2 4 minus 3u plus 1 equals u over 3 plus 2u minus 1 over 5. Okay, so there's like several appropriate strategies for this. Like you can get rid of the fractions immediately. You can hang on to the fractions until the very end. You can do something in the middle. Maybe we'll start off by doing something in the middle. But you know, as we work through more and more of these examples, we'll probably see like all different ways to do it. So what I will first want to do is maybe I'll distribute this half through to both parts of this parentheses using the distributive rule in order to get something on this left-hand side that's a little bit easier to work with. So notice I haven't added or subtracted anything from one side of the equation to the other. I'm just simplifying the left-hand side at this point. So if I do half times 4, I get 2 minus 3 over 2 times u plus 1 equals. Now I really want to think about this u over 3 as being 1/3 u, but we can go ahead and just write it as u over 3 for now. But sometimes you'll want to write it as 1/3 u, like kind of this is 3/2 u. Okay, so now what we want to do is maybe combine everything that we can. So notice that this 2 plus 1 is going to give us 3. So that makes the left-hand side of the equation 3 minus 3/2 u equals u over 3 plus 2u minus 1 all over 5. Now we want to start like making common denominators so we can add these things together. And adding these things together will take us like kind of to the next spot. Okay, so here the common denominator on the left-hand side of the equation will be a 2. So we need to build this 3 over 1 up until it has a denominator of 2. We can do that by multiplying by 2 over 2. And then common denominator over here, we've got a denominator of 3 and 5. So we should multiply until we have a denominator of 15. So we'll multiply by 3 over 3 here and 5 over 5 here. So let's see what that gives us. So over here on the left-hand side, we're going to have 6 over 2 minus 3u over 2. Here we can think about this as like u over 1, so I can write that as 3u over 2. That's sometimes a little bit helpful. And now I have 5u over 15. That's what I get from this term. And then we need to use the fact that we have to distribute this 3 onto both of these to write this as 6u minus 3 over 15. And now we're all set because the left-hand side has a denominator of 2, the right-hand side has a denominator of 15. So we can combine the left and right-hand side together individually. So we'll have 6 minus 3u over 2. So that's what the left-hand side looks like. And then since we've got a common denominator of 15 here, we can have 5u plus 6u. So that's going to be 11u minus 3 over 15, where we combined like terms there. So now we've got this big fraction equals this big fraction. But now we can use cross multiplication. So if these two fractions are equal, we can multiply the 15 up here and the 2 up here. That's just by this equivalent rule for fractions. And let's see what that gives us. So that is going to give us, so this 15 is going to be multiplied up here. So we'll have 15 times 6 minus 3u. So that's that. And then equals 2 times 11u minus 3. And now we're almost there. We can take this 15 and distribute it onto both of these terms. This 2 and then distribute it onto both of these terms. And then we're ready for like the first step of the first example. So 15 times 6 is 90. So this is going to be 90 minus 45u. 15 times 3 is 45. And then here we have this is equals 22u minus 6. Now we can maybe like add 6 to both sides. We want to get the u's by themselves. So let's see, that's going to give us 96 minus 45u equals 22u. We can add 45u to both sides, so plus 45u. So let's see, that gives us 96 equals, that's going to be 67u. Now we can say, we can divide both sides by 67, and we'll get u equals 96 over 67. And I think both of those are divisible by 3. Wait, no. Never mind. No, I think that's in lowest terms. So that's where you would have to stop with that. So like what went on here is we did a lot of simplification of the left-hand side and the right-hand side individually before we got to this point right here. And this is the point that we started applying the two like allowable actions. Multiplying both sides of the equation by 15 and 2. That's what the cross multiplying is. And then doing all of that stuff over there. Okay. So we're pretty much out of time. So I think we'll call it here. I'll maybe put up just 1 or 2 problems on this stuff. That'll be due this Saturday. I think we're having Wednesday and Saturday. So the stuff for today will be due on Saturday. Just 1 or 2 problems, and then we're gonna like dive more into this next time.